a lot of these free response questions are very similar. So I'm going to show you how to solve question number 4 on the FRQs using tables, and then that should help you solve number 5, 6, 7, and 9. They're all very similar. The other questions I wrote out hints for you to help you solve, and remember you only have to pick 4 of these to complete. So the first thing I always do when I'm reading the question is I go through and I make sure that I read the part before it starts asking me anything. So grain is being added to a silo. At time t equals 0, the silo is empty. The rate at which the grain is being added is modeled by a differential function, g, where g of t is measured in cubic feet per minute from 0 to 8. Selected values of g of t are given in the table. And then the first thing it asks me to do, A wants to use the data in the table to approximate g prime of 3. So if I'm going to find g prime of 3, it's an approximation, so I use my squiggly equal signs. And because they're telling me to approximate the derivative, I know derivative is just slope. So in order to approximate the slope at 3, I'm going to choose the point 5 and 1 because they're on either side of 3. Then I just take my y values from there. And I'm getting this right off of the table. Then I'm going to put that in my calculator just to make sure I don't accidentally add or subtract something wrong. And I get 5.4 over 4, which gives me 1.35. Now it also asks me to use the correct units. So in order to know the units, all I do is I look back at the table and I say, okay, way too big. I look back at the table and I say, okay, what were the units for 20 and 15? And I see that it says cubic feet per minute, so feet cubed per minute, over the units for 5 and 1, which were minutes. And I can leave it right like that. I can say this is my final answer. So I always, to get the units, I always do the same thing with the units that I did with the numbers. So since I was dividing the numbers, I just look at what their units were and divide them. All right. Next, part B asked me to write an integral expression that represents the total amount of grain added to the silo from 0 to 8. So it wants me to write an integral from 0 to 8. And they told me that the function in the table is g of t. And since t is my variable, I write dt equals. So there's my integral expression. That's the first part. And then it says use a right Riemann sum with 4 sub-intervals indicated in the data to approximate the area. So if I'm looking at my data, I have 0, 1, 5, 6, and 8. And then I have 12.8, 15.1, 20.5, 18.3, and 22.7. So if I'm going to find my first area, my first rectangle will be between 0 and 1. And because they said it's a right-hand Riemann sum, I'm going to use the value from the right side. So my first area is going to have a base of 1 because 0 and 1 are 1 apart, and a height of 15.1, which gives me an area of 15.1. My second rectangle will go between 1 and 5. Oops. So my second area will have a base of 4, because 1 and 5 are 4 apart, and a height of 20.5, and when I multiply those, 4 times 20.5, I get 82. Now my next area will go between 5 and 6, which gives me a base of 1, because 5 and 6 are 1 apart, and a height of 18.3, which gives me an area of 18.3. And then my last one, a 4, has a base of 2, because 6 and 8 are 2 apart, and a height of 22.7, which gives me a total area of 45.4. And then in order to get the total approximation, I'm just going to add those numbers up. So 15.1 plus 82 plus 18.3 plus 45.4, and that gives me 160.8. So that finishes part B for me. Now part C says that the grain in the silo is spoiling at a rate of W of T, and then it gives me an equation for W of T, where W of T is measured in cubic feet per minute from 0 to 8 minutes. Using the results from part B, approximate the amount of unspoiled grain remaining in the silo. So, in order to find the amount of unspoiled grain, I first am going to look at what I already know. I know that in the silo, the total or the approximate total amount of grain that's in the silo was the 160.8 that I just found. That's how much they told us how much grain is being added. W of T tells us how much grain is being removed. So if I want to know what I have total, I need to know what I started with. So I go back to my equation and I look how much grain was in the silo to begin with, and it says at T equals 0, the silo is empty. So I'm starting with nothing, then I'm adding 160.8, and I'm taking away however much of the grain spoiled of WT dt. And then I'm just going to type this right into my calculator in order to get the final answer. I'm going to remember, in order to type in an integral, I hit math 9, and then I type in the actual integral, and I can type this right in and it'll spit out the answer for me. Logan has decided he needs attention immediately, so I'm going to leave that part